Hello student, the question says a rectangular loop of side 12 centimeter and 5 centimeter with its sides parallel to the x-axis and y-axis respectively moves with a velocity of 5 centimeter per second in the positive x direction in a space containing a variable magnetic field in the positive z direction. The field has a gradient of 10 power minus 3 Tesla per centimeter along the negative x direction, and it is decreasing with time at a rate of 10 power minus 3 Tesla per second. If the rate resistance of the loop is 6 milliohm, the power dissipated by the loop as heat is. So basically, a rectangular loop is given, and this is 12 centimeter, this is 5 centimeter. This is moving forward with a speed of 5 centimeter per second. Assume this is x and this is y. Magnetic z direction would be coming out of the screen. So magnetic field is outside, but this magnetic field is not constant. It has a word gradient. Gradient means anything that changes with position. It has a word rate also. Rate means anything that changes with time. Yes, so let us discuss this word gradient a little bit. If any physical quantity or anything that changes with respect to position, that is called gradient. Okay, so in simple terms, when we say the field has a gradient of 10 power minus 3 Tesla per centimeter along the negative x direction. What does it mean? That means dB by dx. This is when we say dx, we are actually moving in positive x direction. But the author is saying the field has a gradient in negative x direction. So simply it is 10 power. We have to use the negative symbol. So 10 power minus 3 Tesla per centimeter. Can you think about any other chapter where we have a gradient along the negative x direction? If you see a conduction where heat flows from high temperature to low temperature, here also we have gradient along the negative direction. What is the meaning that a gradient is along the negative direction? That means when you are traveling along the positive x direction, the temperature decreases. That is what the negative gradient means. So negative x direction gradient means simply dB by dx equals to minus 10 power minus 3. And here a word rate is also given, but it is given, it decreases. Since it decreases, we can write dB by dt equals to minus 10 power minus 3 Tesla per second. Then let us try to get an expression for an expression for B. I will use the analogy of acceleration velocity. Suppose if acceleration is nothing but dv by dt, right? If you know acceleration is dv by dt and you know that this is a constant acceleration, I won't derive it. We will get v equal to u plus at. It is not that difficult. We will take dt to the other side, integrate on both the sides, and v minus u equals to integral a dt. So you will get at. So this is the expression we got. That means if you have anything that changes with time, the final expression on integration will get v equals to u plus at. But here we have a magnetic field which changes with position. We got dB by dx, we got dB by dt also. So very simple. Here velocity is only a function of time. We will write a magnetic field that is function of both position and time also. Simply let us assume the starting value is b naught. Since here it is a negative value, so simply I will write b naught plus at. In place of a is nothing but dv by dt into t. So simply db by dx into x plus db by, we can write this as u plus dv by dt into t. So db by dt into t. If you substitute it, so b x comma t equals to b naught minus 10 power minus 3 Tesla per centimeter. So I will leave it in centimeters only because the entire question is in centimeters only. If needed, I will convert. So remember, x must be in centimeter because I left it per centimeter. dB by dt is 10 power minus 3. So minus 10 power minus 3 into t. So this is the general expression for B. Once you get the general expression for B, if you observe this question, the coil is moving, but it is always inside this magnetic field only. Since it is always inside the magnetic field, if I try to find the flux in this problem, flux is B into A, then d phi by dt is simply the area that is experiencing this flux. Flux is BA cos theta. If you observe the diagram carefully, here theta is 0 degree. Because magnetic field is in this direction, area vector also is in the same direction. So it will directly simply become BA, and the area of the coil is also not changing. So A into dB by rate of change of flux. So dB by dt. So let me just substitute here. So A into, when I do dB by dt, so dB naught by dt minus 10 power minus 3 would be outside, dx by dt, again minus 10 power minus 3 outside, dt by dt. So we simply get d phi by dt equals to B naught is a constant, so it will become 0, dx by dt, so which is nothing but velocity. And remember, I want x in centimeters because this is in centimeters, x is in centimeters. Here velocity must also be in centimeter per second, minus 10 power minus 3. We know induced EMF is equals to minus d phi by dt. If I multiply the negative sign and bring this 10 power minus 3 also outside, so you will get A into 10 power minus 3, minus of minus, this minus and whatever minus we have, it will become positive. So V plus 1. Now let us substitute the values. The area is given as 12 centimeter, 12 into 10 power minus 2 into 5 centimeter, 5 into 10 power minus 2 into 10 power minus 3. And remember, velocity must be in centimeter per second only. You might wonder why am I solving some of the quantities in SI units and some of the quantities in CGS units. Okay, this is for convenience only. If you want, I will give you this as a homework. Like you try to convert each one and do it, but still we will get the same answer on. So V value is given as 5 centimeter per second. So 5 plus 1. You do it step by, it might look like I'm adding a CGS unit with SI unit. It's not like that. You have to see this 10 power minus 3 into Tesla per centimeter. If you multiply with centimeter per second, centimeter would get cancelled, you will get again Tesla per centimeter. Similarly, 10 power minus 3 centimeter per second, like t by second, it will remain t by second. So ultimately this unit and this unit would be same only. It might look like we are adding two different physical quantities. Okay, so let us do it. So 12 5s are 60 into 10 power minus 7 into 6. So we got 360 into 10 power minus 7 or 36 into 10 power minus 7. He has given the resistance R equals to 6 millivolts, so 10 power minus 3 ohms. What is the value of power dissipated? Power equal to E square by R. We can write 36 into 36 into 10 power minus 7 into 10 power minus 7 divided by resistance is 6 into 10 power minus 3. Don't try to solve this straight away. He has given this must be equal to N into 10 power minus 9 watt. Some people, they will try to solve and then they will try to convert into this form. It is wrong. Always directly find and equate it to N. Your maths will become easy. This is minus 14. And once we get this, so 6 table, 6 times. So 10 power minus 9. Okay, we get it as 36 into 10 power minus 6. So we get 6 and 6. And in most of the integer problems, all the 10 powers would eventually cancel. 9, 10, 11, 12. When it comes to the denominator, 10 power minus 12. Here also 10 power minus 12. So all these 4 we can cancel straight away. So we get N equals to 36 into 6. So it will be N value would be equal to 216. So the correct answer for this problem would be 216 into 10 power minus 9 watt. Once again, I will repeat, remember, it is not necessary that a function only is variable with one quantity. This is a function which is varying with position, varying with the time. So simply write an expression rather than v equal to u plus at, we'll get v equal to u plus at plus some beta x or something like that. And then we substituted everything and solve it like a regular problem, we'll get the answer. Hope you understood how I have solved. Thank you.